Okay, we're well into number sequences, the first topic of semester 1 of unit 3 of 12 apps. We've looked at chapter 4, now we're going to look at chapter 5. That is all about applications of these sequences and use of recurrence relations to solve problems in the real financial world. So in this chapter we're going to be learning how to apply sequence theory to things like costs, investments, loans and depreciations. It is worth noting now, because this is going to come up many times and it should be understood, is that simple interest, which you've met in earlier years, is actually an example of an arithmetic sequence, and compound interest is an example of a geometric sequence. And you may also have heard of the term modelling growth and decay. Well, that's what we're doing. Growth either using the rule or using recurrence relation, and decay is where the numbers go down every time. So starting off, keeping it simple, in 5a we're going to look at this in two parts. The first part is, can you use sequence theory on simple interest rates on savings and loans? And we're also going to be using it for things like hiring a car. In fact, we'll do that first. So we're going to be using the rule, which you've met many times before, and we're going to be using the recurrence relation, which you've met many times before, although this is going to be looking slightly different this time. Starting off using the rule, this is an example where you can solve a problem involving things like car hire. Imagine that you want to hire a car to go away for 10 days, and you want to know what it's going to cost, so you go do some shopping around and you find one place. Sounds very expensive to me, but anyway, it costs $180 flat fee to start with, and then $150 for each day that you hire it, running costs, etc., presumably. Now that problem can be probably solved without using a rule, just using a calculator, but let's apply the rule so we know how to. We want to find the 10th term, so we're going to write T10 equals, in this case, A is the first term, which is 180, and then we want n minus 1, well 10 minus 1 is 9, times the difference, which is 150. I like to put it in brackets even though the calculator will do the multiply first. That will work out as 180 plus 1350, which totals out to, don't forget the dollar symbol, of 1530. And all money answers, if there are any decimals, should be 2 decimal places. Okay, so that's an example of using the rule, which we only kind of come across a little bit. What we're really going to be interested in is using the recurrence relation for finance. And we'll start by solving simple interest problems. Now the first thing that you're going to need to get to grips with is we're not going to be talking about T1 as A anymore. We're going to be finding T0, and that is because, let's say you're going to put some money in the bank. The money that you put in the bank is the principal before you start earning any interest. So T0, if you're putting $1,000 in the bank, T0 is 1,000, and then after the first year of interest you'll find that with V1. Now I'm talking about V because we're going to use the letter V for value instead of T. So if you're doing an ordinary sequence, T1 equals A, that's fine, but in this example it's going to be V0 is the first term. Let's see the whole thing. T1 equals A, etc. becomes V0 is the principal, A, or whatever you want to call it, Vn plus 1 is Vn plus D. So pretty much the same, it's just that you put the starting amount as the 0 term before any interest is added. The number of additions of interest will be whatever n is, so if, for example, the total value after 5 years will be found by calculating V5. Let's take an example. Someone invests $5,000 in the bank and they know it's going to earn 4.8% per annum, simple interest. What is the value of the investment after 5 years? V0 is your $5,000, and each successive term, Vn plus 1, is going to be found once you've got a Vn by adding 4.8%. Now in there we're going to calculate it, 4.8 4.8% of $5,000. That will be added each time. Now the way to do that on the calculator is to say it's Vn plus whatever 4.8% of 5,000 is. Now the way to do that is 0.048 times 5,000, so turn it into a decimal by dividing by 100, which turns out to be on your calculator 240. So there's actually the formula. V0 equals 5,000, Vn plus 1 equals Vn plus 240. And then you get your calculator out and put in 5,000 and press enter, and then press add 240, enter. That's the first one. Another one 2, another one 3, another one 4, another one 5, and you should get an answer of $6,200. Now do that yourselves on your own calculator to make sure that that's what you get. So in summary of what we said so far, if you're doing problems which involve something like finding the cost of hiring a car, where you've got a starting value and then some additional costs, you can use the rule, which will take you straight to the 10th term. Solving simple interest problems, for now use the recurrence relation. V0 equals the principal, Vn plus 1 equals Vn plus d. Now once you've got your head around all that, you can start the exercise 5a on page 149. Questions 1 to 5 use the formula that I've just spoken about, and questions 6 to 10 use recurrence relations. On the second presentation for 5a, you will find out more about depreciation using arithmetic sequences.